Hey guys, Zachariah J here again. IVC Pre-Calc Chapter 3 and 4 exam review. Starting on Part B here. It's going to be 19 through 29. I know in my last video I said I was only going to do 2 videos for this, but I'm actually going to have to break it into 3 because I looked at some of these problems and they're kind of long and long to explain. So I'm splitting them up into a couple. Also, I'm posting this video a little earlier than I said. I had a few people want the content as soon as possible so they can get studying for our test next week. I'm looking at you, Chichery. I didn't even have the last video up for 12 hours, and you're asking for the next one. So, doing my best to get it all done along with all my other stuff. So, we'll get started. But just as a reminder, I'm not the teacher of the class. I'm just a student in the class. So, I may make mistakes. So if you do catch one of the mistakes, it'd be great if you post it in the comments. Also, hit the subscribe, do the like thing, all that stuff. That way you will know when I get the next video up and all that kind of stuff. So, with all that said, let's see about getting started here. So for these first two, for 19 and 20, from the polynomial whose zeros and degrees are given, use the leading coefficient of 1, or form a polynomial, sorry. So here are our zeros, x plus 4, because of the negative 4. If we put negative 4 in there, this quantity would be 0. Same thing for the negative 5, so we do x plus 5. And then we do the same thing for the 5, so x minus 5, that would make those zeros. And our degree is 3, and each of these doesn't have an exponent. I mean, it has one, it's a 1, but we don't write that. So that's done as far as that part is concerned. Our teacher will just accept that as the answer, but if you're doing pre-calc elsewhere or trigonometry, or sorry, not trigonometry, in calculus or something, they'll make you FOIL this out. So I'm just going to show you the FOIL method. I mean, we all know the FOIL method, but I'll FOIL this out so we get the final answer, which is actually the answer that was given to us in our answer key when we were given this test or this practice exam. So this first part FOILs out to this, and then we have x squared times x, that's x to the third, minus x squared 5x squared plus 9x squared minus 45x. Holy crap. It's really hard to talk and do this at the same time. I invite you guys all to try it. It's 100, 22, yeah, 100. All right. So the negative 3 comes down. There's no other, I'm sorry, negative 3, the third exponent, third root, or x power of 3. I can't even talk. No others to combine with that. And then these two combine to make 4 x to the second, and then we got these two combined to make negative 25x minus 100, and that is the whole thing FOILed out, and then every like terms combined. So that's the answer from the answer key. Here's another one. It's a little more complicated because they give us a different multiplicity. I'm trying to enunciate. Um, So, and our degree is 4. But you see both the multiplicities are 2, so we know we're going to have 2 factors here. So x minus 2, multiplicity of 2, so we put the exponent there. And then this is negative 2, so we're going to do x plus 2. And then, again, multiplicity of 2, so we put the 2. 2 and 2 together, degree of 4. So, pretty easy to get to this part. And again, our instructor told us, or told me anyway, that's good enough. But for other people, it might be FOIL time. So we have x minus 2 squared. So it's x minus 2 times the quantity x minus 2, and then x plus 2 times the quantity x plus 2, because we have two squares, right? So x times x is going to be x squared. Let's see if I can just do this all at once instead of drawing it all out. So I'm just going to look at this part of it. And that should be x squared minus 4x plus 4. Yeah. And then the other side is going to be the same, except they're going to be both pluses, right? So this part of it is going to be x squared plus 4x plus 4. Okay, so that's what I can do kind of quickly and in my head. So x squared times x squared is going to be x to the fourth. And then x squared times 4x is going to be 4x to the third. And then x squared times 4 is 4x squared. Now we have negative 4x times x squared, so that's negative 4x to the third minus 16x squared minus 16x. And then FOIL out the 4, so that's going to be plus 4x squared plus 16x and plus 16. All right, so now we have to combine like terms. We could shuffle this all around so they're all together, but just to skip that part, I just like to cross things out as I use them. So I'm looking at the exponent of 4. So I see no other exponents of 4, so I'll cross that out. Now I'm going to do the 3's. So I'm going to underline everything I see with exponent of 3. And those cancel each other because it's a plus 4x to the third and minus 4x to the third. So let's look at the 2's here. So we got a 4 and a negative 16. So that's going to be negative 12x squared. Yeah, negative 12. Right? Yeah, negative 12x squared. And hold on a second. I forgot this x squared here. See, this is why I underlined them. And then I can make sure I got everything together. All right, so I actually have negative 8. And I'll cross those all off. And I have negative 16x and plus 16x. Well, those cancel each other, so that's nothing. And then plus 16. So that is that equation all foiled out. All right, we'll move on to number 22. Find the vertical asymptotes for the rational function. Okay, well, the first thing we need to do is we need to factor this out a little bit. So we'll look at the bottom as x times the quantity 49 minus x squared. And now we can further factor that out into x times the quantity 7 minus x and 7 plus x. Now we can see that we have a kind of a hole in our graph if we were to graph this, but we've got negative, we got 7 minus x and x minus 7. So we can just convert this to a negative 1 up here instead of a 1 because they were transposed. So what we end up with here is negative 1 over x times the quantity 7 plus x. Yeah, that's what's left. There you go. So our zeros are x equals 0 because of the x that's out in front, right? So if that was 0, then, and then we got minus 7 for our other one. So there you go. And I'll just do this a little bit different way to kind of show you what I meant by that negative on the top. We'll just change this around a little bit. So the x leading in the bottom. So I'll factor out a negative x down here, and then I'll have x squared minus 49 on the inside. And so the top is x minus 7, and the bottom is x minus 7 and x plus 7. So now you can see they're actually in the same order. So when I cancel them out, I don't have to add any sort of negatives. So the top is x minus 7, and the bottom is negative x, and then x plus 7. So I get the same zeros And I also have a negative in there, which was this negative x here. So still a negative, right? All right, so 22. All right. So let's factor this guy out. So negative x squared plus 16, right? We'll make it negative. We'll factor out the negative here. And then we get, and now we have a perfect square, which is going to be easy to factor to a negative quantity x minus 4, and then x plus 4. So that's the top of our equation here. And we're going to have to factor out, yeah, so this I brought this from the top. Should have did it all in line, but I'll do the side work for the bottom part of the equation here. And that's going to be, let's see, x squared plus x plus 4x plus 4. Yeah, x squared plus x plus 4x plus 4. All right, so now I can factor out the x on this side. So that's x times the quantity x plus 1 and plus 4x plus 1. So that gives me x plus 4 times quantity x plus 1. So pretty easy kind of factoring there. Some of you guys probably do that in your head, but I still like to write it down. And maybe someday I'll get there all in my head. All right. So just put that over here on our bottom here. Zoink. All right. Well, x plus 4 and x plus 4, those guys are going to cancel out. So I'm going to have a negative times quantity x minus 4 on the top. And I'll have x plus 1 on the bottom. So finding the vertical asymptote, it's going to be -1. That makes this 0 on the bottom. So vertical asymptote is going to be x equals -1. There you go. All right, so we'll move on to number 23. And this says give the equation of the horizontal asymptotes given. I think it should say given the equation, but we need to find horizontal asymptotes, if any. So we have to remember if n is less than m, then y is going to be 0. N equals m, well, then y is going to equal a ratio of the leading coefficient a sub n and a sub m. And then if n is equal to m plus 1, well, that's going to yield us a line. So equation for a line is y equals mx plus b. And that is, like I said, it's a line. Or it's going to be an oblique asymptote. So that's what that is going to be. It's going to be one of the two. Asymptote. T-O-T-E. Hope I'm spelling that right. And then the third thing that we can get is n is equal to m plus 2. And that's basically just going to mean there's no horizontal or oblique asymptote. So what does that all mean? Or oblique. And it's asymptote. Same thing above it. So I'm not going to rewrite it. Except this is, my penmanship is terrible. That's not even a better E. Anyway, so what does this mean? So we're going to look at this, third, x to the third, so the square root, or the cubed part of it, and then x times the quantity x. So we're really going to get a squared, x squared. So n is the exponent on the top, and m is the exponent of the equation on the bottom, or the exponent of the first term on the bottom. So we have 2, and 2 is less than 3. So, I mean, I guess I could have left that. Trying to figure out the best way to explain this so people can follow along, but we have ultimately y is going to be equal to 0 because 2 is less than 3. So like I said, at the top you have x squared minus x, so that 2 right there is less than the 3, which is on the bottom exponent. So we get n is less than m, y is equal to 0. That's the answer. Super simple, but I took forever to explain it. All right, so here's another one. It's the same problem that we need to look at. So we're looking at this leading, not the leading coefficient, but the exponents, and 2 is equal to 2. So as you saw, n equals m. So we look at the leading coefficient at -3 and a 1. This equals -3. So we have a horizontal asymptote at y equals -3. Okay, so number 25, last one of this section. This one, they're trying to throw a little trick in here for you because you want to have these terms in descending order for their exponents, right? So all these 4s here. So we have negative x to the 4th plus 49x, and that is under x squared minus 7. I mean, you don't have to reorder them. You just have to look for the largest one, really, and then of each. But in this case, n is less than m, so we again will have y equals 0, right? So the 2 is less than 4, so y is equal to 0. That one's pretty easy. So now we're going to get into the tough stuff. So we're going to use some of those things that we just did in those last 2 sections to be able to finish these problems, these 4 graphing problems. And this is what's really going to take so long on this video. 4 problems, but it's going to take me like another half hour to do these. But our first thing we do is we factor, and this one's already fully factored. So the second thing we're going to do is we're going to find the intercepts. So first we're going to do the x-intercepts, and to find the x-intercepts, we set y is equal to 0, so this whole function would be equal to 0. So really that's saying setting the numerator to equal 0, so 3x equals 0, and so x is going to be equal to 0 because 0 divided by 3 is 0. So we plug in 0 for y, we're going to get a y for our x, so our x-intercept is 0, 0. Our y-intercept, we set all the x's to equal 0. iPad's doing some weird stuff here. I don't know what's going on. So anyway, 3 times 0 is 0. So the top's going to be equal to 0. So this whole thing is going to be equal to 0. So again, we have a y-intercept of 0, 0. You input 0, you get 0. So third, we need to find if there are any, we need to find all the asymptotes. Vertical asymptotes, the way we find those, as we saw earlier, is we look at just the denominator and find our zeros here. So here we've got -5 and -3. So x, whoa, -5, x, -3. All right. So now we need to find our horizontal asymptotes. Totes. And we did that by looking at the leading coefficient. We looked at the exponent So the bottom we have x squared, remember, because we have to do this. And the top we have 1. So n is less than m, so y is going to be equal to 0. So we have a horizontal asymptote. And now, since we have a horizontal asymptote, we need to see if there's a horizontal asymptote intercept. So the way we do that is, since y is equal to 0, we go back to our original function and we set y to 0 and see if we can find a value for x. So, oops, I don't need the right function there. I don't want function at 0. So I just want 0 equals 3x over the quantity x plus 5 and x plus 3. So this, again, is going to be pretty much the same as us finding the x-intercept, because the bottom multiplied times 0 is 0, so we get 0 equals 3x, and then x is going to equal 0. So we're going to have 0, 0, which is kind of cool, but it's a bummer at the same time, and I'm going to show you why. Because now that we have all this information, we can now start graphing. So time to graph. So, and I was lacking today and I didn't pre-draw my graphs. Come on, why does that make me a straight line? Oh, I need to turn on the ink to shape part. Ah, whoa, what is that? Okay, straight line there. After I get done with this problem, I'm going to restart my iPad. I think just haven't restarted in a while, so maybe too many programs. Get this all straightened out here. All right, so, whoa, yeah, let's try and make it through this problem. All right, so my intercepts, let's look at all of those points that I found, and they're all the same. It's 0, 0, so we'll put a point at 0, 0. And that's all we really know right now. But let's see if putting up our asymptotes helps me at all. So I have an asymptote at -5 and -3, and it's 0 for horizontal. So here's the one at -3. Now remember, this is a vertical one, so I'm drawing a vertical line. Here's the one at -5. And then, of course, I had that horizontal one at 0, so it's really at the x-axis, but I'll just put a dotted line here so we can see it. Now, I see that I'm going to have to do a little side work here to find another point, because I only have one point. I don't know which direction I know that the line has to hug the asymptotes and it's going to cross, but I don't know if it's this line or this line. It could be one of the two. Which one is it? Well, the only way that I know of to figure that out is to just do this extra side work here. So just selecting a random point for x, which I'll just use 1 because that's really easy, and plug that into our original formula and find out what I get for y. So 3 times 1, and then 1 plus 5, and 1 plus 3. So on the bottom, I'm going to get, gosh, yeah, this thing is really lagging now. 6, and I get 4, and this is 3, so that's 3 over 10. Oh, no, 24, yeah. And that's going to be 1/8. So for 1, I get 1/8 for my y value. So I can plot that, but actually, yeah. So I can plot that right there. It's like just barely over the line at 1. So this means I know for sure that this is my line. It comes from -infinity and then comes up, crosses the origin, and then goes through here. So now I'm looking at these other asymptotes. They're all odds, right? So that means the next section over, it's going to go to infinity, but it's not going to go to infinity the same direction as the previous one. So I know that this is going to, triangles. This is going to be a parabola between these two asymptotes, but it doesn't touch the x-axis. And so that means that this one is going to be below the x-axis because it has to go to the opposite infinity than the previous. So there you go. All right, I'll restart it here. Hopefully it'll go smoother. Do number 27 here. A little bit of a trickier one because our factoring, we gotta sort this all out and get it all into common denominators and whatnot. So x over 1 minus 9x. So x over x times x over 1 will give us x squared over x, which now we have common denominators between these two. So x squared minus 9 over x. That's our real function here. And then, of course, we can factor that x squared to minus 9 is going to be um, x minus 3 to, and then x plus 3. But to find our x-intercepts, we can just do it this way, where we have x squared minus 9 equals 0, which means x squared equals 9, which means x is equal plus or minus the square root of 9, plus or minus square root of 9, and that means we have x is plus or minus 3. So our x-intercepts are 3, 0, and negative 3, 0. So again, that's just setting our numerator to 0 and then finding our x-intercepts. To find our y-intercepts, we're going to set our x to 0 to find that, but as you can see, we would end up with 0 in the denominator, and that would be undefined, so we would not have a y-intercept here, so no y-intercepts. So now we need to find a vertical asymptote. So to do that, we find what would be 0 in the, find our zeros in the denominator, and we just found that from our y-intercept check. So x is equal to 0. That's our vertical asymptote. And so now we need to find our horizontal asymptote, and that, if you remember, is looking at these exponents. Let me clear this out of the way so we can see what we're doing here. This, whoa, cleared out too much. There we go. Okay, so x on the bottom is x to the first, but you see the top one, x to the second, is obviously bigger. 2 is bigger than 1. But remember, we had a rule that was n equals m plus m. That means we have an oblique asymptote. So that means we don't have a horizontal one in this case. So none for this, but we do have an oblique asymptote. So we need to figure out what that is, and the only way to do that is long division, which really is a bummer. Makes me sad because this is something I don't do very well. I mess it up often, but x into x squared plus 9, well, x, so x times x is x squared, and we're going to subtract that, so that gives us 0, and then we're going to this remainder 9. We don't care. So y is equal to what's on the top there, which is x. So y is equal to x, not 0. What am I thinking here? Erase that. The magic of erasing. It's this x up here, so y is equal to x. So our oblique asymptote is y equals x. Well, now that we know we have an oblique asymptote, we have to find out if we have an intercept on it. So to do that, we need to put x equals our function. So x is equal to x squared minus 9 over x. Well, x times x is going to give us x squared equals x squared minus 9. And if I subtracted x squared from both sides, I get those cancel. So I get 0 equals minus 9. That, of course, does not equal. So we do not have an intercept on our oblique asymptote. All right, we're ready to start plotting or graphing. I'm just circling all the things that we will need to use to graph this function. So we will start off with, come on, give me a straight line. There we go. Draw a graph here real quick. See if I can get a horizontal straight line. Sweet. Straighten them out and get them on the grid here so it's easy to see where we're plotting. There we go. All right. First things first, let's start with our intercepts. Start with our 3, 0 and our negative 3, 0. So let's do this. This is the third one. There we go. And then there's the third one there. So there's our intercepts. That's everything because we don't have a y and we don't have a asymptote interception. So let's draw those intercepts, or not intercepts, asymptotes. So we have 1 at x equals 0. So it's a vertical line right here on the y. It is the y-axis. And then, of course, we have this uh, asymptote, or sorry, oblique asymptote, y equals x. That's a line. And just to remind you, if we put in 1 for x, we're going to get 1. If we put in 2, we're going to get 2, 3, 3, negative 6, 6. I'm sorry, negative 6. So it's basically a slope of 1. So starting at the origin. So we'll just draw this diagonal line that basically goes through all the same point coordinates. Is that even a thing? 1, 1, or same? Well, I don't know. Anyway, we know that this is going to go this way, and the other one's going to basically just do the opposite. And so that one's pretty easy to plot. Remember, it doesn't touch those asymptotes. Kind of got that one touching, but this is really like this guy. So there you have it, number 27. So we'll move on to 28 here. And first, again, we got to factor this out. So we got x over x minus 5 times quantity x plus 5. So there we go. That part's all factored. So now we're going to find our x-intercepts. That's setting the numerator to 0, basically, which basically just gives us our x-intercept, which is x equals 0. So we'll find our y-intercepts. We'll make all the x's 0. Well, you'll see that we put 0 on the top. We're basically going to get 0 again. So this is similar to a question a couple questions ago where we had our x and y intercepts were both the same, which was 0, 0. So now we need to find our vertical asymptotes. So we just look at the denominator and find our zeros in the denominator. And we find that x is going to equal 5 and negative 5. So we have both of those. And then, of course, we're going to find our horizontal asymptote. And that is looking at the exponents of the upper and lower. Now, remember, we have a x times x on the bottom, so that's x squared. So technically our m is greater than n, so it's y equals 0. So do we have any intercepts on the horizontal asymptote? And so we just make this equal to 0. And x over x squared minus 25. And then, of course, that's going to make this be 0 equals x. So, yes, we have an intercept. And it is at 0, 0. Same as all of our other intercepts. So everything is happening 1,000 points of light, as George Bush Sr. would have said, all happening at 0, 0. All right, so we have enough, or all our information we need to start graphing. So we'll draw our little graph here. And give me a second to straighten these guys out a little bit. They were pretty close, actually. Getting better, but not good enough. All right, so first off, these are our asymptotes. So let's just draw those in first, just for fun. There's our vertical at -5. And of course, we have a vertical at 5. So put that one in here. And then we have our horizontal one at 0. So 0, of course, is our x-axis. Might be kind of hard to see this going along that black line, but we have one at 0. Now we have our intercepts. So, and they're all 0, 0. So again, we got this crazy situation where we have 1 point to deal with. So how do we know which way our lines are going to go on our graphs here? Well, you guessed it, side work. So again, I'm just going to use 1 because 1 is usually pretty easy to put into the equation and figure it out. No use making it like 15 or something stupid. So we got 1 over 1 squared minus 25. We're going to still turn out with a fraction, so 1 over -24. That's our y. We can't simplify that any further. So it's a crazy number. That means it's going to be way in here. Like it's even closer to the line than this. But all I need to know is the fact that it's negative for me to understand where to put this line. It means that this half is this way. It goes through the intercept and it goes this way. Just the fact that I know that the y is negative at 1, at positive 1, tells me this. Now I go back to looking at my multiplicities, and I find out that they are odds. So 1 and 1 and 1, they're all odds. So that means these are going to go to infinity in the opposite direction of the, just over the asymptote. So these are my other two lines for number 28. All right, on to our last one, number 29. So for this guy, we got to factor a little bit on the top here. So let's get this to be x plus 1, x plus 2. And then on the bottom, we're going to x minus 2 squared still. I mean, we could put that as x minus 2 times x minus 2, but it's kind of redundant because they're both the same. It's not going to affect the rest of our asymptotes and all that stuff. So we're going to find our x-intercepts. So that's setting the numerator to equal 0. And we're just going to end up with -1 and -2. So I'll just write those down here. So those are our 2 points, -1, 0 and -2, 0. Find our y-intercepts, and that is setting all of our x's to equal 0. So we'll just put this so we can end up with -1, -2 over -2 squared. Yeah, this will be -2 squared. Yep. So that is going to be 2 over 4, which is 1/2. So for x of 0, we get 1/2 for y. So our y-intercept is 0, 1/2. Yay! All right, so we're running out of room here, so I guess I'll go back over here and do our vertical asymptotes, or VA. And we just look at the denominator, and 2 would make that 0, so x equals 2. There's our vertical asymptotes. And then now let's look at our horizontal asymptotes. So basically, we got to look at our leading coefficient, or our leading exponents, or our leading coefficient, the leading term's exponent. And wait a minute, why do we have x plus 3ax? In this case, we're going to end up with n equals m, because this actually should be an x squared. And then on the bottom, x minus 2 times x minus 2 gives x squared. So we'll get a 2 there. So we'll look at the leading coefficient, which is 1 over 1, which equals 1. So our y is going to equal 1. So now that we know that we have a horizontal asymptote, we need to find out if we have an intersection of that asymptote. So we set our whole function to equal 1. So we have, I'm just going to have to put the 2 up here. This was supposed to be here, but I forgot to copy it in. And now I keep trying to make mistakes here. 2. Back to blue. All right, 2. All right, now we have the right equation here. Sorry about that. So, and then in the bottom we have x minus 2 squared, or the quantity x minus 2 squared. And actually I'm going to have to we'll multiply that times 1, so that's going to be x squared plus 3x plus 2. So we're actually going to have to multiply this out. I thought I could get away from not doing it, but it's going to be, there we go, not putting the squared in there again. There we go. And x3x plus 2, there we go. All right, so the x squareds are going to cancel each other out, because if I subtract x squared from either side, or from both sides, they're just going to be gone. So that leaves me with negative 7x by switching and combining like terms is equal to negative 2. All right, so if I divide by negative 7, so this is, oh, come on, negative 2, negative, and 7. So a negative divided by a negative is going to be a positive, of course, so these change to positive. So for an for a y value of 1, we need an input of, 2 over 7, so 2 sevenths. So I just put 2 sevenths, comma, 1. So there's our horizontal asymptote intercept. So we actually have a whole lot of stuff to actually plot on this one. It's a little more fun. So I'll circle all the components here that we need to do our graph here. See, this is a lot of work just to do one graph. Okay. Wish me luck here. We'll try and draw some straight lines again. Where to put this? Here we go. Ooh, straight line on the first try. Let's see what happens here. Oh, I jinxed myself by saying something. Let's try again. There we go. It's not straight. Straight-ish. All right. Fix this all up here. All right, what to do first? Draw the asymptotes or draw the intercepts? Let's draw the intercepts. So I have negative 1, 0, and negative 2, 0. Then, of course, I have this 2 sevenths 1, so it's just like barely off the y-axis there, but at 1. Then I have 0, 1 half. So I have a whole bunch really, really close. Let's draw this x equals 2 asymptote. And of course we have this one at y equals 1. So draw this one through here. And remember, it's going to go right through this point here. And that's okay because we calculated that we'd have a horizontal asymptote intersection. So now we get to start drawing some lines. All right, so these little guys here in the middle, obviously they all connect somehow. So I'm just going to connect all these guys. And then you can see it's supposed to go through here, but then there's this point right next to it. So it's going to come back up, go through here, and then hug the asymptote here. So, and then we can finish off this one over here, hugs this asymptote. So that's this side. But how do we figure out which one of these two lines is it? I don't know. I don't have any points over there. So what I'm going to do is I'm going to look at the leading terms exponent value, which is 2 and 2. They're even. I mean, remember, we're going to get x squared here because if we, expanded it, we get x squared, as we did before. So that means if they're even, they go to infinity on the same side or in the same direction on either side of the asymptote. So that's how we know which side that goes on. So that's number 29. That's the last for this video. This video is long enough. I'm going to do another video, the third installment for this review, here either tomorrow or the next day, and that's going to be 30 through 36. Again, remember, don't use this video as your substitute for practicing and actually physically writing on paper yourself, because if you're writing it on paper and going through the steps, it's going to force you to have some sort of muscle memory, making you remember how to think about these problems and things like that. And again, I'm not an instructor, I'm not a teacher, just taking the class just like the rest of you guys. So if you saw that I've made some mistakes, please put them in comments, or even if you have questions of why I did certain things certain ways, if you're confused, hit me up in the comment section, or if you see me in class or around in the halls. Then of course, our teacher has a whole lot of office hours, so you can go check with them. And IVC has an awesome program where it's an open entry to the Math Center, and it's free. It's not for any credits, but you basically can go in there and get free tutoring for all your math. So I don't understand why people don't do that. There's no requirement of doing a certain amount of hours or not. So you should capitalize on that and check with your counselors or check with your teacher and find out how to get into sign up for that. So anyway, talk to you later. See you on the next one. Bye.